In this video, I'm going to do number 25 in section 0.5 of Anton. The question says, solve for x without using a graphing calculating utility. Use the natural log where any logarithms are needed. So the question number 25 says 5 to the negative 2x is equal to 3. So what I really want to encourage you to do first is to just think about what does the graph look like. So I'm just going to show you kind of my initial view of that. 5 to the negative 2 to the x, you can put parentheses around 5 to the negative 2. That's 1 over 5 squared, which is 1 over 25 to the x. And if you remember in class, we looked at this graph, and we're showing that when b is between 0 and 1, which it is in this case, it's 1 over 25, then the function is going to go from positive here, very positive here, to approaching 0 once we get past the point 0, 1, but it's going to include 0, 1. So I just made a quick sketch here. I know it's going to cross at 0, 1. And what we're interested in is the value for x that's going to make this function 3. So where is the y value equal to 3? So we can see it's going to be a slightly negative number, but we're not exactly sure what. So when y is 3, I want to know what this value of x is. So now that we have a graphical picture of what's going on, let's take a look at the algebra. Actually, I can show you the actual graph. It does look just sort of like that, and so we're interested in the point right here. So if I put a point on the function, the value right there, and so it looks like it's going to be a pretty small negative number. Alright, so let's hide the graph there. I'll hide my point. And now here's the algebra. Hopefully you can see this. So we have 5 to the negative 2x is equal to 3. Well, if two quantities are equal, then their natural logs are equal. So I can say the ln of 5 to the negative 2 is equal to the ln of 3. Well, another rule for logs is that you can, when you multiply, when you raise a power to a power, you multiply. So I'm going to take this power and multiply it by this power. So I bring that basically down in front. So we have negative 2x times ln 5 is equal to ln 3. Now we have negative 2x. I divide both sides by ln 5, and you're left with ln 3 divided by ln 5. So finally I want to just divide by negative 2, and I'll have x alone. So I have ln 3 divided by negative 2 ln 5. Now one of the things that students commonly do is they'll say, well, ln 3 over ln 5, isn't that ln 3 over 5? And as you can see here, these are not the same values. Ln 3 over ln 5, you can imagine it's 0.68. So when you're dividing it by 2, it's going to cut it in half. And when it's a negative, it's going to be a very small negative number like 0.34. So I hope that this video has helped you understand both conceptually and algebraically how to solve this problem.